Hello, and thank you for joining us today as we hear about the clinical user experience with MVision AI. My name is Katie Regan, and I'm a Senior Account Manager with MVision, and I'll be moderating today's recorded webinar. Joining us today from UMC in Lubbock, Texas is medical physicist Ryan Schurr. Ryan was born and raised in Tampa and was introduced to medical physics at the end of his high school career through the parent of a friend. Because of this, he had the somewhat unique experience of completing his entire college career with the intention of being a medical physicist. He got his BS in physics from Clemson in 2012, his MS from LSU in 2015, and completed his residency at Baylor Scott & White in Temple, Texas in 2017. And he has been at UMC for nearly 6 years. When asked about his interests and hobbies outside of work, Ryan responded with, well, what do those words mean, interests and hobbies? But he went on to say he spends the bulk of his free time with his wife and their dog, and he also dabbles in speed solving Rubik's Cubes. His current record is 11.32 seconds. And he's in the market for some suggestions for more relaxing hobbies to pick up later this year. So Ryan will go ahead and go through his presentation, during which time you're encouraged to use the Q&A feature if you have questions, and we will keep time at the end of the webinar to answer those questions. So welcome, Ryan.
Thank you. Thanks for joining me today. As Katie said, my name is Ryan Schurr. I'm the Chief Medical Physicist at the University Medical Center in Lubbock, Texas. I've been an MVision user for maybe a year and a half now. If I had to guess, I would say that we've maybe done a few hundred cases through the auto segmentation model to date. I'm going to try to keep this about 30 minutes. Sometimes I guess I like to hear myself talk and we could run a little longer, but the first 20 minutes should be all about the auto segmentation workflow, results, the impact that it's had in my clinic. And then in the last 10 minutes, I'm going to kind of go over some future things that MVision is working on that I'm personally excited for, and felt the need to include it here. So with that, the first thing I want to cover is the workflow of how we get the data to the cloud and back. Then go over some use cases for physician contouring. I guess the main selling point to actually getting it implemented here was the physician contouring. A few cases for OAR segmentation that I find to be particularly helpful personally. And then touch on some statistics as I guess the FDA clearance of MVision has had in my clinic here. And then end with a brief look at some future projects underway. So there's currently two possible workflows to get your CT data to the cloud for the auto segmentation models and then back. The first is a DICOM daemon. We're still in the process of getting this set up in my clinic, so I don't have any firsthand experience with it. But the general thought process, you have a DICOM daemon lives locally on a hospital server, transfer your CT data to the daemon. The daemon pseudonymizes it, basically strips the PHI data in a way that when it comes back, that PHI data can be reattached to it before you import it into your TPS. So that CT data then goes to the cloud. The auto segmentation happens selected automatically based on DICOM header info that hasn't been stripped. Comes back to your DICOM daemon, gets transferred to your TPS import location. And then from there, you're free to kind of carry on your normal planning, contouring process. So the process that I've been using since day one here has been a web access portal. I'm kind of a control freak, so personally, I like being able to lord over all of these individual steps with an iron fist as they happen in front of me. So I kind of like the web portal personally. So I start by exporting my CT data to a pre-configured network drive location. Then fire up your favorite web browser. I personally use Chrome. I think any browser should probably work as long as it's not like Netscape Navigator maybe. And you sign into the web portal using a Microsoft Azure authentication. This is the landing page. So you just click on that Choose Files button, pops up a Windows dialog box. From there, you can, for me, we're a small clinic, I can just sort it by date modified, and it's basically immediately obvious what images you want to select just based on, hey, I know that I just exported this, and here it was May 4th, so select those and upload them. The web portal will pseudonymize them before that data is transferred to the cloud. Once that data is transferred, you're introduced to this kind of like three-plane DICOM viewer. You can click on that new structure set box in the upper left there, where you get a drop-down menu, select the model of choice that you want to run. It looks like in this case, we ran the abdomen and lung SBRT auto segmentation structure set. There's a quick confirmation that you chose the right one, just so you don't have to wait for it to process, and then close out of it, re-upload it, contour it again. And then from there, the auto segmentation process kind of goes on. This case looks like it took just over a minute to complete. And once it's done, your three-plane view gets updated with all of the structures contained in that structure set that you had put on. You can close out of this, kind of scroll through it if you want, or at this point, I just immediately download it and save it to my TPS import location, import it. Personally, I like to keep an untouched copy of the MVision contours, and then as I see ones that I want to use, copy them over to my actual like planning structure set. So that way, if I like edit things and break them, I don't have to go back and reprocess it again. But I guess that's kind of a user preference from my end. And before we move on, I also want to say that there is a separate configuration web user interface that you can sign into. You can choose to exclude structures from the models there. Like there's some like muscle and bone helper structures in some of the pelvis sets that I have excluded. Or if you don't like the default colors, you could change them to something. Or if you wanted to track usage statistics separately, you could track them there. But yeah, so with that, let's jump into taking a look at some of the contours. So we'll start with the head and neck cases. This is probably the biggest selling point that we had when we went to administration and said, hey, we want to implement this. So MVision is going to contour bilaterally where relevant, and separately the neck nodal levels 1A through 10. So we'll play through it here as we get a little lower down to the more common nodal levels. You can see that it does a pretty good job grabbing those nodal spaces. As we get down to our dental artifacts here, we see that the contour is not really impacted by all of that dental artifact. As we scroll down, it still looks pretty good, excluding the muscles, excluding the bones, excluding the cartilage. There's maybe a few places towards the bottom here where you get maybe some like stray pixels or little islands or like super thin areas of contouring where you might want to go back and kind of fill it in with the brush manually. But overall, our physicians here have been super happy with the results to the point that sometimes they get a little frustrated if there's someone with like significant surgical defects where there's a little more than normal brushing touch-ups needed. But overall, it's usually pretty incredible. Since these are all separate and generally, you want to have maybe like 2 or 3 different dose levels in your target volume, got a little post-processing routine that I like to run. Certainly, we don't need all of those nodal levels for most cases. So we're just going to do a Boolean operator and a clip to combine all of the ones that you want. In the example case here, I think we're going to see ipsilateral only, level 2, 3, 4, and 5. And then I like to give it a small isometric expansion of about 1 millimeter. And that just helps those little islands or those thin areas, it kind of like fills them in. And then you can apply a high, like not super high, but kind of moderate high in Eclipse. I use like level 6 or 8 or so level of smoothing with the post-processing tool. which in turn kind of like shrinks down that isometric expansion that you gave it. And so you end up like filling in the islands, connecting things, but also not really changing it too much. And then I guess depending on how much time it takes you to do the touch-up, you can reclaim probably anywhere from like 45 to 90 minutes back into your day. So our physicians have been very happy with it. So in our example here, we're going to see our post-process structure in red, and then we're going to see the relevant unedited MVision structures in their original colors. So if we play through it here, we see maybe the expansion that I used was probably 2 millimeters here, maybe could have been 1. You know, you might have to go back in and do a little bit of erasing out of bones. If you get too close to the mandible, maybe you'll have to subtract out the mandible, maybe crop it so it's not going outside the body here. Definitely take like a big 3D eraser brush, take the clavicle out of it, take the lungs out of it at the bottom here. But overall, you can see it's pretty good, maintains the same general state. You know, it's smooth, it's very, like, you don't get big changes from one slice to the next that you might get if you were like individually hand drawing every slice. So it makes even like planning conformality easier when you don't have these big jumps in the structure state from one slice to the next. In the past, we've sat with our physicians while they were drawing with the RTOG nodal atlas pulled up next to us. So overall, this saves time for the planner in my institution, at least saves time for the physicians. And again, overall, that's probably the biggest selling point that we took to administration. Like, look at all of the time that this is going to save our physicians when they're drawing targets. So I know there's a lot of physicians that maybe aren't so big on drawing target volumes for breast cases. I know in my clinic here, we don't usually, but every now and then we'll get a patient that's enrolled in one of those like Alliance or NSABP like clinical trials where they give you like a page and a half worth of instructions on target design. And for those cases, MVision will contour left and right individually the supraclavicular nodes, and then either the full axilla together or separately levels 1, 2, and 3, along with both the left and right breasts if you need like a whole breast contour or something. The supraclav nodes are dubbed level 4, I think the European name, and then we'll also get the internal mammary nodes in the first 3 intercostal spaces. And so as we get to the bottom here, maybe a little bit of touch-up needed, like the very bottom of the breast contour. But overall, these are usually pretty darn good nodal contours to the point where you may not even need to do any sort of post-processing routine on them. I have an example of using the post-processing routine to follow here. As we get to the top there. So again, those are all separate. If you want to combine them together, you can with a Boolean operator. If you don't, and you just wanted to do like that isometric expansion, high level smoothing, any kind of like brushing to remove any bones that you might have inadvertently expanded into. Then again, reclaiming, those are usually pretty time consuming for us at least to draw by hand. So I'm thinking probably 45 minutes or so, you get to reclaim back into your day. So as we play through here, we'll have our post-process structure in red and then the original unedited MVision contours in their, I guess, normal standard default colors. So as we play through this, you know, I did go back and subtract out lung and clavicle here in the post-processing. There's not really a difference between them. But if you look at the internal mammary nodes, definitely our post-processing routine here, I think, made them a little worse. So if you do a post-processing routine on them, I would definitely say, at least in my experience, the post-processing is not necessary for the internal mammary nodes. But overall, you know, we're pretty happy with them. We've used it a handful of times for the clinical protocols, and it matches basically exactly what the instructions tell you to do. All right, so then the last of the helper target contours that I want to show comes from the male pelvis with lymph nodes model. It does a 2008 RTOG guideline for pelvic lymph nodes for prostate cancer. So it's going to start at the L5-S1 interspace and extend inferiorly to the top of the synthesis pubis. As we scroll down here, maybe there's some areas that we want to go back, connect with the brush, maybe do some erasing, make it maybe a little more symmetric. We'll get a seminal vesicles, we'll get a prostate, maybe some minor erasing out of the space OAR, like hydrogel spacer there. I'm going to engage in some speculation here. I don't believe that there's hydrogel spacer in the training data, but guys, correct me if that's wrong. But still, it does a pretty good job, even in the presence of it. So again, I've got a little post-processing routine that I like to run through here. Nothing to add together since it's just that one contour, but I'd still like to give it a little expansion. In Eclipse, there's a post-processing tool that has a connection feature that'll take like little islands that are separated by some distance and connect them together. And I found that like 1 to 2 centimeters here usually does pretty good. Then a like very mild level of smoothing. The auto segmentation model contours muscles and bones if you want to just like Boolean operator subtract those from your post-process structure. Or you could take a 3D adaptive eraser brush to subtract it out and then reclaim 30 extra minutes to your day. With a universal ground truth in radiation therapy as a whole is that your therapist hides snacks at the treatment console or nearby. And 30 minutes is the perfect duration of a snack break. And then when they ask, hey, where is my food going? You can practice this with me. Must have been the service engineer. So if we look at our post-process structure in red here, original structures in the normal, original default colors, we see that it's a little better. We get some connection where we wanted it. Maybe we'll have to go back and still do a little bit of touch up with the brush, but not too bad. Overall, the physicians are pretty happy with it. We've been using the male pelvis with lymph nodes model on our female pelvis patients, just so we can kind of like feed in this nodal contour structure here. But I will say I've heard that there's a female pelvis model with lymph nodes, I believe, in review with the FDA right now. And that's going to include the, para-aortic lymph nodes as well. And then I've also heard that they're in the process of updating the prostate nodes to match the 2021 NRG update. That's going to take that up to the bifurcation of the aorta. So looking forward to those. So with that, let's jump into some of our OAR segmentation that, as a planner, what I guess what I'm here for. For head and neck, it'll contour your optic structures, chiasm, optic nerves, eyes. Usually pretty good. Typically, your target volumes don't go up that high, so there's really no need to edit them. The parotids and mandible are usually pretty good. The oral cavity and lips are good, even in the presence of that dental artifact, still do pretty well. And then, we get a brachial plexus, spinal cord is pretty good. Esophagus is usually always pretty good, maybe minor touch-ups at most. And then the lungs, I don't think I've ever edited in my history of using it here. We'll play through this one more time. Maybe there's a little discontinuity for a splice or two between the brainstem and the spinal cord that I would go back and kind of brush in there. And then the compartments of the larynx are segmented individually. So usually I'll kind of do a Boolean operator, combine them all together to get a single larynx contour. But overall, head and neck OAR contouring is usually a pretty time-consuming endeavor. And I really don't regret it as much as I used to now that I have the auto segmentation for it. For the breast OARs aren't usually horrible, but we've already run it for the target volume, so we should Really, I feel like for the most part, you can take these contours and you don't need to edit them at all. Like the lungs are always good. The esophagus is usually good. Maybe some touch-ups on the contralateral breast side. Our case here, there's some distension of the esophagus that you could maybe go back and fix there. The top of the heart, you could maybe make a little more circular. But at the end of the day, there's certainly nothing really clinically relevant that I think you would need to go back and touch up. It'll contour liver for right-sided cases. Our patient here had a lap band surgery, so there's not really a good stomach contour to show. But overall, for the most part, you can just copy these structures and use them minor touch-ups. That's a very worst case. And after this, we'll move on to our pelvis. The top here. One of my least favorite structures to draw by hand is the bowel bag. Our structure set here is going to come over with the bowel bag, as well as a separate small bowel and large bowel contours. Admittedly, there's typically some touch-up needed on the large bowel, but it makes for an okay starting point if you want to like contour a sigmoid colon or something. As we get a little lower here, we'll see maybe we need a little touch up at like the very top of the rectum. But the bladder is usually pretty good. Where we get to the hydrogel spacer, maybe we want to go back and erase that, erase the rectum out of there. Then the femoral heads are typically pretty good. Definitely the superior parts of them are awesome. The very bottom, sometimes I go back and just with like an adaptive brush, add in a slice or two at the very bottom. But overall, it saves a bunch of time. Maybe do a little touch up with the bowel bag and kind of like that inferior, posterior aspect of it. But as a whole, it's been a welcome change to not be drawing these by hand, I'll say. And then something that is probably my least favorite thing as a whole to contour by hand is lung SBRT cases. So the first case that we're going to scroll through is actually the first case that I ever ran through the demo back like maybe 2 years ago now. And this was, I think, what sold me personally on AI auto segmentation. So the brachial plexus looks great. Spinal cord, trachea, esophagus looks pretty good. The aorta, here our patient had some mediastinal adenopathy. And even in the presence of that, the aorta looked pretty good. And that's what really sold me on it, I think. Maybe like 4 or 5 slices of esophagus to touch up there. But as a whole, the chest wall looks great. And that usually takes a little bit to get contoured. Yeah, so this was the thing that really sold me in the very beginning. So I've got a second case here we can scroll through. This data set runs a little lower. We can see a few extra OARs here. The aorta is pretty good. The lungs are pretty good. I think if we looked at it in the lung window, we would see that there's maybe some motion artifact around that trachea, which is why we might have been tempted to edit it a little bit on our average data set there. Maybe some minor touch-ups on the esophagus, but the liver is usually excellent. The stomach is great. The esophagus runs into the stomach. You get pretty good colon. Bowel bag, those are relevant for the case that you're contouring. But yeah, I would say in the time before, when I was finishing OAR contours for lung SBRT cases, that's now the time when I'm completing like the end plan and then running off to grab the physician to review it. And so with that, I guess let's segue into taking a look at some of our planning timeline statistics. This was absolutely not a prospective study. This is just, we had some process changes, we had some staffing changes. So definitely, some confounding variables in play here. So I've got a little box plot of our planned turnaround times between when the plan is ready to start OAR contours, so like the sim is complete, contours are complete. through the time when that treatment plan needed task in ARIA is completed, and we progress on to the kind of ready for approval task. So for the pre-MVision data, I went back and collected a couple months worth of data from, I think it was like early January, February 2021. And then the post data comes from like the first 6 months after the MVision FDA clearance. And so if we look at it, our turnaround times, I guess we can say generally got more consistent in the at least inner 50%. And then also if we look at the median turnaround times, we're cutting maybe a day and a half to a day and a quarter off of that. Certainly we're not spending a day and a half or a day and a quarter doing OAR contours. But I guess psychologically, I think there's some things in play where you gain a little time back in your day, like in addition to just contouring. So like maybe you were finishing your contours at like 11:30 in the morning. It's maybe easy to say like, whew, now that that's done, I'm going to come back after lunch and get started on the plan. Whereas now if you're, hour and a half earlier, suddenly at 10 o'clock, you've got time to start, maybe finish that plan, saving, 2-3 hours off of what you were doing before. So you get half a day if it runs over to the next day, like maybe it's the end of the day, like, oh, I'll work on it tomorrow. But now, you could finish the plan today, get it approved today. So there's some room for improvement there. And I will say that those decrease in treatment times have also been accompanied by having less staff working on the plan. We went from 4 total planners to 2 total planners in that same time frame, and still decreased the turnaround time. So maybe the next thing to look at would be our sim to start timeline. MVision got FDA clearance in May of last year. I think it was like mid-May of last year. So as it became like widely adopted in our clinic, we'll like highlight those 2 months in red. So if you look at the months before, you've got maybe 9.5 days on average for our sim to start timeline. Then if you look at our 6 months afterwards, that's been shaved down to really on average just under 6. So, you've got a 3-day turnaround time improvement. Again, like OAR contouring is not going to account for all 3 of those days. But certainly if you're able to complete the plan a little bit faster, they get out to the therapist, the schedule just a little bit faster. So maybe they're able to get a hold of the patient during business hours, day earlier than they might have been otherwise. Get the patient in to start on a Thursday when they normally would have had to wait for a Monday to start if we were calling them Thursday or Friday. So maybe the other thing at play here is we moved from purely electronic communication to me approaching the physicians in their offices, knocking on the door. Hey, there's a plan ready for you. Let's come now, take a look. And I can be pretty annoying and persistent, I guess, when I put my mind to it. But yeah, overall, I'd say probably it's fair to credit maybe 50% of these improvements, I think, just to the widespread adoption of AI-guided segmentation for contouring. And so with that, we're going to move into our kind of speculative future projects underway section. There's a project underway to generate a synthetic CT from exclusively MRI data. So I guess you feed it some number of MR series, and it will output a like treatment planning quality CT scan for you to work with. Similarly, I think there's a project underway to generate synthetic CTs from exclusively cone beam CT data. Again, treatment planning quality CT from just your kind of like noisy, scattery cone beam image. Maybe you could combine that with the next project of dose prediction to generate kind of a best case treatment plan that you can then use to kind of guide your planning process towards that. maybe work at like same day plan adaptation if needed. And then they're going to continue to work on the AI guided models, if there's new guidelines, like updating the 2008 prostate to the 2021 NRG update, get some progress there, some like optimization structure generation, which may actually already exist in the configuration workspace. But truthfully, I haven't had a chance to get in there recently and really play around with it. But the project I want to touch on today is the dose prediction model. I got to take a look at it maybe a couple months ago now, and haven't had a ton of time to work with it, but I'm pretty excited about it. So let's see what it looks like. The general process that I see it working isn't like, so you don't send the CT data to it and collect a treatable plan back from it, but you do send your CT data to it. You have your OARs and targets included with that. The model is going to predict what an optimal kind of best case, or maybe not like objectively best case, but like excellent near best case plan would look like. And then from that, you can, it'll figure out like what good objectives to use in your optimizer would be. And then maybe like Fever Dream in the future, use Eclipse scripting to enter those automatically, get the optimization going automatically maybe. And since those are already like best case objectives, it takes all of the iterative optimization process of decreasing your OAR objectives, waiting for the optimizer to improve, decreasing them a little more, until finally you reach that point where you can't decrease them more, because you're already kind of starting at that best case scenario. So you can kind of just like maybe once decrease them to see if you can make it a little better. And if you can't, then you can relax until you get the target coverage that you want, and then you've got a plan ready to review. So certainly, I think as a human planner, it's very easy to get distracted during the optimization process. My belief is that optimization is a pretty interactive process, not just like type your objectives in and close your eyes, but like actually get feedback from the optimizer, make changes where necessary. And I think decreasing that interactivity needed from the planner is going to take your overall plan variability and make like all of your plans more similar to each other, decrease variability, while at the same time driving your average plan quality towards that sort of best case scenario. And for my dosimetrists, I guess I want to say this is not like the robot coming to take our jobs, but it is going to free up our attention to direct it elsewhere where we could make improvements elsewhere. While at the same time still maintaining like a high quality product from our, this is an AI generated, I think the prompt was robot supervisor. Yeah, kind of drive us all towards the best case. So truthfully, I've looked at exactly one patient with this dose prediction model. And so this is our clinical plan here. We've got our 50% isodose line in blue. It was generated by one of our dosimetrists, I want to say back in like early 2021 or so. So yeah, quantitatively, we met all of our dose constraints. Qualitatively, we had that good 50% isodose line kind of coming up and bisecting the rectum there. So yeah, looks good. We treated it. Everything was good. And then a few months later, we sent the data to the dose prediction model. And, I took the target objectives that my dosimetrist had used, deleted all of the OAR objectives, inserted the objectives that the dose prediction model had recommended for me, and just ran a single reoptimization. When I optimize, I'll always let the optimizer do an intermediate dose calc in Eclipse, and then complete after like backing up to step 3, do another intermediate dose calc, and then from step 4 onwards. So I always do that as a person, so I figured I would give the optimizer the same chance to do that here. And then if we look at our AI guided plan here, qualitatively, it's maybe a little hard to see the improvement, even if we put them side by side. But we did see quantitatively a nearly 3-grade decrease in our bladder mean dose, a 4.5-grade decrease in our rectal mean dose, and then a femoral head max dose decrease of 6 gray on one side and 9 gray on the other. So again, you put them side by side, kind of hard to tell qualitatively if one's objectively better than the other or not. It looks like our AI guided plan, maybe we sacrificed a little bit of conformality kind of in that posterior section. But when you overlay the deviations on top of each other, I think you see just a tremendous gain in kind of that low intermediate dose, kind of high intermediate volume region of the deviate. So we've got the penile bulb in pink, where there's not really a big improvement. The femoral heads in teal and lavender, where you can see both a big decrease in the max dose and a pretty significant decrease in that kind of like intermediate volume receiving low dose. And then we've got our, I guess, functionally relevant yellow and brown bladder and rectal contour or structures, where you can see pretty significant savings in like integral dose to those, especially in the kind of low intermediate, high intermediate volume regions. But it's one case. I didn't want to be unfair, pick a plan where the planner maybe got distracted, had their attention called away and called out to the machines during the optimization process. So I figured I would do my best effort to generate what I think is the best plan that I can generate independently. And so we'll have my plan on the left, we'll have the AI guided on the right. So again, we see maybe the AI guided plan sacrifices a little bit of conformality for maybe a little more avoidance of the femoral heads and rectum, but qualitatively, it's very, very difficult side by side to tell. But when you overlay the DVHs again, we'll have triangles for the human plan, we'll have squares for the AI guided plan. We see for the femoral heads, I was able to kind of meet that same max dose, but certainly the integral dose for the femoral heads is a lot better in the AI guided plan. And then it looks like the AI guided plan still beat me on the integral dose for the rectum. And I was able to improve the bladder a little bit, but still, the AI guided plan is a little bit better than me still. I'm not going to sit here and say, I'm the greatest planner to ever walk Earth. But I do a fair amount of planning, and I like to think that I'm fairly proficient at it. So I think we really are approaching kind of a best case plan with our dose prediction model. So really, I'm hoping to have some time in the next month or two to really get my hands on it and play with it and see see what comes out of it. But yeah, overall, I'm very, very excited for what's coming. With that, I want to thank you for your time. Thank you for dealing with my rambling and my little home away from home here. Turn it back over to the MVision panelists.
Excellent. Thank you so much, Ryan. We do have a couple questions, and I'll just go ahead and read them. But as we answer questions, if you come up with more, everybody's encouraged to use the Q&A feature to do so. Some of the questions make more sense for Ryan, and some of them make more sense for MVision to answer. So I'll briefly introduce Jarkko Niemela. He is a PhD physicist, but he's also our company CEO. So he will be helping answer questions as well. Let's see here. I gotta minimize some things so I can actually read these. Okay. So first question is, will you be adding space OAR to the structure set?
Thank you, Katie. I guess I can answer to that. Thanks. So yes, we are, and we already have done it, outside of US. And the update, FDA update, will have MR T280 model that will have a space OER and Barrigel, both spacers, to be auto-segmented and detected.
Excellent. Thank you. Second question is, when will dose prediction upgrade be available? I think that might be also a Jarkko question.
Okay, yeah, Katie. So we are looking at a timeline for the next year. So it will be available next year.
Perfect. I think this is a Ryan question. We can also chime in a little bit if we need to, but can you talk a little bit about what the actual implementation process was like?
Yeah, so there was a little bit of maybe like IT security bureaucracy navigation in the very beginning. But with the web portal, there's really no like to configure it. You just get your Windows Azure credentials, no real like configuration needed on the user end. Then for actually getting it implemented, I probably looked at 30, 40 cases, the contouring results before I started using them clinically. But at the same time, every contour that comes out of it, I guess as a human, I feel like we still have the responsibility to review all of them. So really each patient that comes out, gets a full, like before you use the structure, it gets reviewed.
Great, thank you. Couple more here. Is MVision capable of performing Boolean operators? I know the answer to that. It's yes, but I'll let Jarkko or Ryan get maybe in a little bit into the details of it.
I think Ryan showed, how he does with his treatment planning system, the post-operations, but the answer is yes, indeed. MVision has a full set of features configurable where post-processing steps can be created. Now, that can be done for all the automatically segmented structures or ROIs. Later on, we will update the system such that when a planner, or rather the oncologist, has created the planning target volumes as well, then MVision will process together with that any type of PRV volumes or optimization volumes for you.
Perfect. Next question. This one's a Ryan question. How difficult was it to learn the software? Just generally speaking, maybe scale of 1 to 10.
Well, if we say how difficult was it, where 1 is super easy and 10 is hard, I would put it, I guess, at a 1.
Okay.
Like really using the web interface is pretty, I guess, straightforward as a like primary Windows user for my whole life.
Sure.
Pretty intuitive, I think.
Excellent.
Katie, I interrupt and just comment here that indeed the web user interface is very simple, and the other way to use the MVision is having configured the automatic daemon networking, where scans are sent from CT scanner to the daemon server at the clinic, and then they will be processed and automatically forwarded to the treatment planning system.
So 2 different versions of easy is what you're saying. Yeah. This is a question I think directed, it can be, we'll direct it at both of you. So we'll have Ryan make an estimation, and then Jarkko, you can make a company-wide estimation. But the question is, how many scans have you processed using MVision?
Well, so we run almost all of our patients through MVision for auto contouring. So I would guess over the past year and a half, maybe 400 cases through there.
Okay.
I guess we could go back and get like official numbers from the.
No, I think just a general, what level of experience are you talking from, I think is the point of the question. 400 is a pretty great number. Jarkko, do you want to talk a little bit about total number we've processed so far?
Sure. Total numbers are probably somewhere at, close to maybe 250 or 300,000, but annually we are already processing more than 100,000 patients in these 15 different countries where we are active.
Okay, excellent. Let me just make sure I'm not missing any other questions. I think that wraps it up. So I guess just thanks again to Ryan for your excellent presentation and for all the participants for joining us and asking questions. The webinar recording will be sent to everybody who registered within the next week, and it'll be available to non-registrants by request through MVision. So you just got to reach out to one of us and we'd be happy to send you the link. Just thank you again for joining us, and we hope you enjoy the rest of your day.
Thank you very much.